This is the last lesson of chapter 1 of our Algebra 2 course. We're going to be talking about compound and absolute value inequalities. Excuse me. So we're going to take the last lesson. We're going to kick it up a notch or two. This is all theoretically still review from Algebra 1, probably, but either way, we're going to tackle it kind of like it's brand new-ish. So we're going to do just like we did last time. We're going to hit several, or a few, not several, but a few problems, and then we're going to peace out and you're going to take a test and all those things. So here's the first one. Solve 8 is less than 3y minus 7 is less than or equal to 23. So we have a compound inequality here. So the reason why it is a compound inequality is because you notice that there are two inequality symbols. So this particular inequality right here is typically or can be called an and inequality, right? So and the way we could write that is we could write, if we wanted to write this in and form, right? We could rewrite this as 3y minus 7 is less than or equal to 23 and 3y minus 7 is greater than 8. So these two are equivalent forms. So that's just, I'm just throwing that in there more as kind of a review that these two things are the same. They're functionally equivalent. Now, so as to what to do with this problem, this is less useful. Although you can, if it's in this form, you're kind of doing the same thing as what I'm about to show you. You just kind of do it in two separate things. We're going to do this all in one thing. So what when we have an equation, you have something like and equals, right? We think about it as having two sides. And, what you've learned since middle school and all those things is if we do something to one side, you have to do it to the other side, right? If you add something over here, you've got to add it over there, right? And so that's kind of how we've done things. Now, when we have a compound inequality, what you can think of instead is you can kind of think of it as being like three sides, right? So our goal is to get the variable that's in the middle. We want the variable in the middle and by itself. That is our ultimate goal there for this thing. So it's kind of like solving a regular equation, but instead we're going to have kind of two answers with inequality symbols in between them, right? And so we do it the same way. So we're just looking at this little chunk right here. And we're looking at that and we're saying, okay, what's attached to the y? Well, the 3 is and the 7 is, right? How are they attached? Through multiplication, through subtraction. We're going to get rid of the subtraction first because it's easier, right? Right now, so far, it's the exact same thing. The thing that we got to remember is that we are going to add 7 to get rid of it, right? To get the inverse. But the trick is, and I still, even after teaching this, I see students make this mistake. So make sure you do your homework and make sure you practice this and you do it right so that you are better prepared for quizzes and tests and all of those things. So like I said, there are three sides. So if we do it in the middle, we also have to do it on this side and that side. You see how there's three different zones here. And that's important that we understand that. You might even draw these kind of dotted lines across. That way you can kind of remember that there's three different things. Kind of like you may have been taught when you learned equations for the first time to kind of draw that dotted line over the equals, right? Same idea. So on the inside, this middle one, the 7s cancel. So 8 plus 7 is 15. And then we have a less than, and all that's left on the inside is 3y. And then on the right side, we have 23 plus 7, so it's 30. Okay, so we still need to get y by itself. That's still the same goal. Same goal as normal, right? So how is the 3 attached to the y? It is multiplied, right? So how are we going to get rid of it? Well, the opposite of multiplying is dividing. So we're going to divide 3. If we do it here, we've got to do it both there and there, right? Make sure you do it in all places. Now, I will note that the same rule that we remembered in the last lesson, if this was a -3 and we were dividing by -3 on all of those places, then we would have to flip those inequalities, both of them, around. Okay, so that rule still applies here. So I'll throw that out as a truth to lock in the brain or write in the notes or both, right? 15 divided by 3 is 5, is less than y, is less than or equal to 30 divided by 3 is 10, right? Now we're going to graph our solution set on a number line. So I'm going to draw in my number line, right? Now this time I have to put two things on there because I have 5 and I have 10, right? So I'm going to put a 5 on here. And then I'm going to put a 10 on there. For my class, now this is, if you're not in my class and you're just watching this video to learn this topic for some other class in high school or college or whatever else, your teacher may want this differently. For my class in Algebra 2, this is perfectly acceptable. Just having those two marks on there, as long as they're positioned on the correct side of each other and all those things, it's totally fine. So on the 5, we're going to have an open circle, right? Because there's no equal to. So it's an open circle right there. On the 10, it's going to be a filled in circle. Now, when you think about which direction we can shade, now, normally you're kind of shading in the direction, essentially the equality. Like, so if it's this one is y is less than 10, it would be shaded that way. This one is kind of written backwards, right? And so it's the other way around. So we would shade, we're shading less than 10, so that's this way. But it's greater than 5. I know this is the less than symbol, right? But the y is on the greater than side. If we flip this around, it would turn into y is greater than 5, right? So we're going to shade greater than 5, less than 10. So we're going to shade in between the two of them. Oops, I don't know what I did. I do know what I did. All right, so that's how it's going to look when we shade in the answer. Now, I will note it is possible on these here that if it's written in an and format, and if it's written in this format, it's hard to get what I'm about to show you. It's hard to describe what I'm about to show you in this format. But if it's in this format, there can be a situation where we shade nothing. So like if we got x is greater than 2 and x is less than -1. So we've got 2 and we've got -1. Whoops. -1. So if this was the problem and it was written this way, we would end up with a solution that is the null set, which is that. Because there are no numbers that are both greater than 2 and less than -1. Those don't exist. There's not a number on the earth or in the universe or anywhere that is both greater than 2 and less than -1. So if we are in this format, we do have the possibility of getting the null set, which is nothing. Which is a way, there are multiple ways to write nothing in math. One of them is 0, of course, right? Another one is the null set and all those things. That means that this set that we're trying to graph is nothing. There's nothing. So that is possible. That's not this example, but I wanted to note that because we don't have an example that does that in these that we're practicing through. Let's do the next one. Okay, so this next one we're solving. Now this time you notice, now I said there was and format, right? This time we have or format, right? So this is different. The word or is different than and. I don't know if you knew that at this point, being, like sophomore or junior or whatever you are in high school, or in college or whatever else. I know it's rocket science, not rocket science. It's mind-blowing that or and and are different. They are. So let's take a look at how this works. Okay, so this time we have two different inequalities separated by an or, and so that's that's kind of how we're going to deal with them. We're going to deal with them that way. So we're going to basically solve each one of these little ones, and we're going to solve them for k in this case. That's the variable of choice. So I'm going to rewrite them. just to make our lives easier. I was tempted to be lazy and just go from the top, but that's not good practice, and so it's not good for me to show you bad lazy practice. So we're gonna do this way. Okay, so we have that with an or in between, this or that. So we're gonna solve these. Excuse me. We're gonna solve each one of these separately. So this guy, we've got a 6 attached to k. How is the 6 attached? It is attached through addition, so we're going to subtract 6 to get rid of it. This one, while I've got my secondary color, I'm going to go ahead and do the secondary steps as well. So I've got 3 attached to k through multiplication, so I'm going to divide to get rid of it. Divide by 3, divide by 3. Cancels, cancels. So we're left on this first equation with k is less than -10, or k is greater than or equal to 14 thirds. Now, this is an acceptable answer in Algebra 2, right? Now, I will note, and this one, since we got one of them being negative and one of them being positive, it's what I'm about to say is a little bit more moot. But whenever we're going to graph a number, our brain doesn't think very well in improper fractions. So even though I would accept an answer like this, when we're going to graph it, it's really more useful to rewrite this in its mixed number form, right? So the mixed number here would be, what is that? 4 2/3. Because our brain kind of understands where that is better than 14 thirds. 4 2/3 is kind of almost 5, right? Again, it's less important since we got a negative, because we know that one's going to be on the left, and we know that the 4 2/3 is going to be on the right. So, it's kind of a moot point, but just because that's a good idea. Now, so let's see if we can graph our solution set this time. Now, so we're going to put circles at -10 and at 4 2/3. So at -10, we're going to put an open circle. Oh, phone buzzed, notified me of some nonsense, and then it decided to commit suicide. I think it's fine. Probably shouldn't say that. I'm probably going to get banned for that since I'm going to put this on YouTube. I don't know. Find out. See what happens together, I guess. Okay, 4 2/3. This one's going to be a closed circle. What's going to be really annoying is if you can't even hear it on the audio. I think you'll be able to, but I don't know. Find out. Find out later together. So this or means that either one of these statements can be true. So this time we could, and in fact, you're going to see that we are, spoiler alert, or you can have things that are shaded on the outside if you have an or on there, because they can be true if this is true or this is true. If this word was and, then this particular problem would give us the null set as an answer. So let's take a look at what we're doing. So it's less than -10, which is that way, or greater than 4 2/3. So this time, because it is an or, we can actually shade on the outside, right? And so that's important, that we can't shade. We wouldn't be able to shade this if the word was and right there, because both things would have to be true at the same time. This one, it can be either one or the other. All right, so there you go. There is or and all of those things. Okay, so we've got 2 more examples. Let's do them. We're going to do some absolute value ones. So we're going to do 2 of these little baby ones to kind of get this. You know what? I changed my mind. I don't think we need 2 of these baby. We do, actually, because of, never mind. I didn't change my mind. We're going to keep going. Here we go. All right, so we do these just like we do a equation, like if this was an equals. So when we have an equation with absolute value in it, what did we have to do? Well, we had to solve for the absolute value part, right? Which is already done. Both of these 2 are pretty easy. And then we have to split it into 2 separate problems. We're going to do this exact same thing here. Now, on these, we're going to, since this is Algebra 2, just like we did on the previous one, we're kind of going to use the shortcut method, but something is going to get added. Let me show you what I mean. So for the positive version, it's going to be just the thing, right? So this would be x is less than 3. For the negative version, we're going to go ahead and use the shortcut and already put the negative over here, right? So we've already divided by -1, but what does dividing by -1 do? It flips the inequality. So this one would turn into x is greater than -3, right? So let's graph this one, right? So we've got -3 and 3, both open circles. X is less than 3, so that's this way, and it's greater than -3. So there is the answer to that one. Easy peasy. All right, let's take a look at this one. So we're going to do the exact same thing. We're going to split this into 2, right? So the positive version is just going to be what's written there. X is greater than 5. The negative version, again, we're going to use the shortcuts since it's Algebra 2, x, but it's going to flip because we divided by a negative. So x is less than -5, right? No big deal so far. Let's graph the thing. We're going to put a -5 and a 5. We're going to do 2 open circles. So it is x is greater than 5. That's this way. And less, or, these are all or. It's worth noting. Or this one. And you can check, a way to check to make sure that you've done these right is you can pick a number that is in the solution set. So like something that's over here. So say 10. If I put 10 in here, the absolute value of 10, is it greater than 5? Yes, it is. So this works, right? If I put something over here, absolute value of -10 is +10. Is that greater than 5? Yes, so that also works. So that's the way you can check to make sure these work. You can plug something from the shaded region back in and see if it works. And if it does, you've done everything right. Let's do one more. We're going to do a little bit bigger absolute value. Now we're going to do this the same way. I'm going to go ahead and rewrite it. So we've got, absolute value of 6. Well, I don't know why I wrote it so ginormously, but I did. Here we go. 6y minus 5, absolute value greater than or equal to 13. We are going to first and foremost, we're going to split this into 2. And so the positive version is just going to be the thing without the absolute value, right? Just like it always is. 6y minus 5 is greater than or equal to 13. We're going to use the shortcut. So we've got 6y minus 5. It's going to flip because we divided by a negative, is less than or equal to -13. Now we're going to solve each one of these baby ones, right? So we're going to add 5 on all the places because it's the same on both of them since we used the shortcut and didn't use distributive property and all that other stuff. So now we've got 6y is greater than or equal to 18. Ooh, look, that's going to come out pretty. 6y is less than or equal -13 plus 5. The signs are different, so we subtract and keep the sign of the bigger one. So our answer is going to be -8. 5, yeah, I don't know. That my brain broke for half a second. It's fine. It's fine. It's totally fine. It looked wrong. Definitely. Hold on. Pause. My notes page wasn't flipped over. We're good. I was afraid I had made a mistake. Anyway, continuing on. This guy, what do we have attached to y still? We have 6. Same thing over there. So we're going to divide by 6 with this one. We're going to divide by 6 with that one. Those cancel, leaving us with y is greater than or equal to +3. or y is less than or equal to negative 8/6, hate that word, which reduces to 4/3 when 4/3 is 1 1/3, right? Let's graph the solution set and then we're going to be through. So we've got negative 1 1/3. We've got positive 3. We've got filled in circles because of the equals to. And it's greater than 3, so that's this way. Or it is less than negative 1 1/3. That's all she wrote, folks. That's it. Hope you've enjoyed this chapter. If you're one of my students, I'll see you in class. Study for your test. If you're not one of my students, thanks for being here. Hopefully this has been really useful to us. Let us know in the comments how else we can help you with math, science, or homeschooling in general. We will see you later.